I'm gonna turn this shrimp into chitosan. So what is it? It's a biopolymer which is made out of chitin in the shrimp's shell. And it has a wide variety of uses. It's been used as a pesticide, it's been used as a fining agent, it is used in medicine as a coating because it has antimicrobial properties, and it's even been looked into as a battery electrolyte. I would not be surprised if someone's calling it an aphrodisiac at this point. The first step in the process is, of course, separating the shells, which have the chitin in it, from the rest of the shrimp. This is done by hand because the actual edible part of the shrimp is not used for this, and I want to eat it. Now, back to the medical uses of this. Chitosan is used because of the antimicrobial properties, but also other effects that it has is that on contact with blood, it thickens the blood, which means that it's being used in bandages to close wounds. And as you might expect for something that's used like that, it's biodegradable and it's biocompatible. And economically speaking, you would want to use this because shrimp shells are a very abundant byproduct of the fishing industry, and yeah, it's the second most common polymer in nature, only beaten by cellulose. Now, some problems that arise in this that I do not have access to a laboratory. I'm doing this in my kitchen. What this means is that I do not have accurate measuring equipment. The reagents that I have do not say directly what their concentration is. And my fume hood is me opening the kitchen window. If you want to see how chitosan is made with these things taken into mind, there's about a year-old video on the Fourth Emporium channel that does this actually well. Now, the first actual reaction is going to be the demineralization of the shells, which means removal of the calcium carbonate. This can be done with a weak acid. I'm gonna use vinegar and citric acid for 2 separate batches and see if they differ in any way. They should not. After about 4 hours, the acid has done its job, and now we can wash it away. This means throwing the liquid through a coffee filter and then throwing water on it until it's no longer acidic. Of course, some problems arose because the acid would just eat through the coffee filter, I guess. And to solve that, I had to make this contraption out of a honey pot and the same paper. And it works. It does separate the acidic liquid from the shrimp flakes, with the exception that it's making a huge mess and it's somewhat slow. Luckily, I've been in a chemistry lab, so I know how to solve this problem. Now that the flakes are dry and no longer acidic, we have to remove the proteins, which is done with a strong base. And it's going to be the sketchy part of this whole project because we are going to have to boil it for an hour. The first boil is just because of the proteins. We are not deacetylizing it just yet. And between these 2 boils, I am going to filter it into powder form. I'm just not going to show that because it's the same thing all over again and again. Now, the deacetylation, the second boil, This is supposed to be done with a very strong solution of sodium hydroxide, and there is a chance that this is not going to work because the drain cleaner that I'm using is only at most 30% by volume, and it might not be enough. The second boil was 3 hours, and this is what we got from that. After filtering this comes the solvent casting phase. For this, diluted vinegar is used, as chitosan only dissolves in slightly acidic solutions. It then has to be mixed for a while until the chitosan dissolves. The initial result of letting it dry for a few days resulted in this wafer-like structure. This is due to there being chitin left in the chips, which are however held together by something. I made a second pass of solvent casting, now with sieving out the chitin to try to get a film purely out of chitosan, and the result was a layer of polymer in the glassware, but I could not really test it in any mechanical manner, for it could not be removed in any other form than powder. Now I have my suspicions that this is a rather low yield for what I should be getting, and I suspect that the low concentration in the hydroxide is one of the problems, in addition to me not really being able to measure stuff. But yeah, this is the product we got.